Eric?
Thank you, Jen. So first session is this morning is basically for the breakfast session, right? So if you don't get a croissant, you have a cookie. That's, I think, the good timing, right? Basically, I found a problem, I being based in Belgium, with some content providers that stop deploying IPv6 for a very stupid question. We work at RIPE, or in the ITF in my case, mainly at layer 3, but then sometimes failures happen in layer 7 in the application. And here is why. You remember that HTTP protocol does not have any state. Every time you send a new request for a new page, a new get, a post, a put, or whatever, there is no state in it. The server is stateless. The way we keep states, like a shopping cart, for instance, it's simply by using cookies. And how does it go? Quick refresh. On the left, the customer. On the right, the server. And the big blue stuff, it's a big database. So we start. You log in. You send your username and your password. The server does some checks. It generates a random number, which is the cookie. And it stores in the database with the key, being the cookie. It stores your name, the status, like you are authorized, and it creates a shopping cart, which is, of course, in the first transaction, is empty. And it stores your address, because there is an attack that I will not describe that is basically called cookie stealing. So now, it's sending it back. OK, you authorized, nice picture, or blah, blah, blah. Empty shopping cart. In the HTTP header, it sends a cookie. You keep the cookie. And for each and every new click on the same website, this cookie will be sent into the HTTP header. So I want to buy food. Here's my cookie. Server checks in the database a cookie. Which line is it? Oh, bingo. You are authorized. You are John Doe. I am adding this to your cart. And you get on your cart, which is food now. Next one, I want to order bar. Here's my cookie again. Look into the database, indexed by the cookie, found the record, you authorized, you're coming from the right address. And basically, I can add bar, and then I can say, hey, indeed, bar has been added to your shopping cart. This is quite common, right? If you look about session ID, PHP session ID, that's everything is there. That's the only way, basically, to get a long-term state management of HTTP. So far, so good. Came the world of normal IPv4, came the world of CGN, and came the world of dual stack. So now, what if we start a session with address A, right? We get the cookie C, first letter, of course, and then the server use the cookie with the IP address as a check. And the reason is this. There is no more username and password sent, right? If I go to a couple of slides back, we do not send on this slide the username and password anymore. We simply send the cookie. Anybody that can get the cookie can fake you. Okay? Because the cookie is enough to go in the database, find yourself, find the username, your privilege, and so on. Cookie stealing could be happen if you sniff the traffic in path, or it can be done by hostile malware like some JavaScript. It's pretty common, by the way, this attack. So one way of fixing it is simply checking by the server whether the cookie is really coming from the right guy and the right address. But, as I said, if you do this and you start with A, and you remember API ball, first transaction is over IPv6. Then v4 is becoming faster than v6. Guess what? You switch to IPv4. You change your IP address. Or they are pretty bad CGN. They do not follow this RSC 6888, where you get multiple public address on the CGN, and the same inside customer, subscriber, when it's translated for once, it use address A. When it comes back to the same CGN, address A has been completely filled by other customers, it switched to address B. And then maybe after address C. Here we go. Same thing, right? We start with address A. Hey, I'm John Doe. Please log me in. Yes, you are John Doe. Generate a cookie. I remember your address is A, and you are authorized. OK, now I got the cookie as before. Now the address is changing. Bad CGN, API ball, or other ways of changing address. Going back, here is my cookie, but then A. I cannot find it because you are not coming from the right IP address. So what I say, you are not authorized. It simply happens because for us in networking, changing of IP address, I mean, it's normal, right? That's just a location somewhere in the network. In the application, they use this location as identification, which is wrong. And there we go. Two Belgian websites. Belfius, connection mistake, and specifically for people here from Holland, that should also be in their bed sleeping rather than working here, like a couple of countries here. Rabobank, it's a big Dutch company, bank. It's also existing in Belgium. They say disconnect, timeout. And the first time when it arrived to the end user or to the help desk, can you imagine? That's because somewhere a CGN was behaving badly. Okay. And shame on my employer, Cisco.com. We have one application that does this. So if you're using API Ball to go to Cisco.com or part of it, and you switch before V6, boom, you become disconnected, which is kind of annoying, of course. So impact, in the small country of Belgium, I know two big banks that basically fall back to IPv4 only. They stop completely the deployment of dual stack. Because it's not a single technical change anymore. They need to change the complete security of their session handling, which is way more than enabling V6 on a server load balancing, obviously. So it's slowing down. So in summary, addresses, as we know, it's simply location. Don't use it for identification. For sure, we know it. Application people do not know it. Okay? It's common. I talk about API Ball, but it's not only API Ball. It's CGN. Same thing if you have a GSM with 3G and Wi-Fi, and you switch 3G Wi-Fi, bingo, you get the same problem. You are losing your session. The only way out on the technical means is multipath TCP. But how many people are using multipath TCP? Besides Siri on iOS, nobody. So back to square one. I am working with OWASP, which is the security people working on the web, to change their web page because they say, advise, please check the IP address with the session, which is, of course, wrong. And that's it. So I had 10 minutes. I think I'm less than 10 minutes. So any question?
Yeah, Wilhelm Böddinghaus. I've got one addition. Windows 7 and Windows 8 use a temporary address for outgoing connections. Usually the time frame for that address is 1 day. But if you turn that down to 1 hour, this could happen in the middle of a session. So you don't need IPv4 and IPv6 for changing addresses. You can do it with IPv6 only.
Absolutely. And I think, Jen, when I presented to the IETF, you told me the same thing for iOS device that simply change of IP address every time they wake up. Same problem. You're right.
Hi. Janugo Prins from BTB. I think the problem is rather very old, way older than IPv6. We are running a hosting provider, and we have like turned off IP checks about 10, 12 years ago, because what we see is that big companies have outgoing NAT devices or proxies that are doing exactly the same. Just switch IP addresses in the middle of the session for any user inside the company. So IP checks are nice, but most of the time they simply don't work, and just use HTTPS and make sure your cookies are safe.
I do agree. But people need to learn about it. And the issue of your customer, they were using proxy, so the subscriber were in the enterprise. Home banking, usually you do it at home. This is where it is more obvious there. But you're right, nothing new.
Ilyich from Benham. So when you first started talking about this, it seemed like it was a CGN problem, and I thought, why are you bringing this even up in IPv6? But it's a broader problem because even if we say to the people implementing Net64, don't do it this way, just keep a stable IP address, which seems reasonable to me. And I think we mentioned that in the RFC, didn't we? But anyway, it can happen for other reasons as well, like happy eyeballs, or even when I'm on my phone and I walk out the door and I go from Wi-Fi to 4G or whatever. So this is unavoidable. As far as I understand, is that the people that make these cookies, they do this to avoid stealing cookies, which is a big security problem. So then what is the solution?
The solution, I mean, we need to get this working.
Yeah,
So
but how?
That's a question I'm asking to everyone as well, right? I'm reporting the problem. No, honestly, my point of view on it, and I'm a security person, so we need to protect the cookies itself more now. In the browsers, they're much more resilient to session cookie stealing, because you can really say, never leave, never get access outside of my website. JavaScript cannot get access to it. When you send the cookie, you can say JavaScript has no access to it, so you cannot save it. And if you are HTTPS on the way, it's very tough now to intercept the session cookie. If you remember Firefox and Facebook years ago, it was damn easy because nothing was encrypted. Now, SSL sessions are there, so you cannot steal there, and browsers are protecting the cookie inside the browser. So we can, I think, slowly relax the link between the cookie and the IP address. Anyway, we can steal it, right? If you are behind the CGN with, I don't know, 1,000 people, you share the same address. So you are losing in this way. Not easy, though. Not easy, though. That's the reason why it's blocked.
Thank you, Eric.
You're welcome.
Next speaker, Wilhelm, will talk about my favorite topics.
The extension headers. Good morning.